Yes, students, in the present class, we shall discuss about the reactions due to alpha hydrogen in the aldehydes and ketones. These reactions proves the acidity of the compound. Let us see how. Okay, let us consider a carbonyl compound. Let us consider a carbonyl compound like this. And here there is a alpha carbon. Assume that here we have alpha carbon having hydrogens like this. It may be any group linked to this carbon. Okay. Now we know this carbonyl group is polar one because the most electronegative oxygen pulling electrons towards itself. So that the carbon will lose the pi bond and becomes trivalent. So that what it will do, it will pull the electrons from the CH bond like this. So it results into this RCO minus. Okay, then C double bond CH. Okay. Now this one is stable. This one is stable because there exists a resonance structures. There exists a resonance structures like this. Or see, if this jumps here, this jumps onto this carbon like this. Negative charge will be there. Okay, these are having resonance stabilization. Resonance stabilization. Due to the resonance stabilization, a proton is lost. A proton is lost. The removal of hydrogen. Removal of hydrogen. Where this hydrogen is removed from the alpha carbon, this carbon is called as alpha. Why? Because the carbon which is adjacent to the carbonyl group is called as alpha carbon, and the next would be called as beta carbon. Okay, removal of hydrogen from alpha carbon in carbonyl compounds. In carbonyl compounds results in acidity. Results in acidity. Okay. Yes. Due to the acidic nature of the carbonyl compounds, these react with the bases. Due to the acidity of carbonyl compounds. Due to the acidity of carbonyl compounds, it reacts with bases or alkali. It reacts with bases or alkali. Okay. So the carbonyl compounds where alpha hydrogen is acidic in nature, due to that reason it reacts with the bases. One such reaction is called as Aldol condensation. It is called as Aldol condensation. Here we are going to discuss about the Aldol condensation. Aldol is a type of compound. What is the aldol? Aldol means beta hydroxyaldehyde. Beta hydroxyaldehyde. Here we also get the ketone. It is a beta hydroxy ketone. When you take a ketone as the reactant, you will get a ketone as the product. If the reactant is an aldehyde, you will get a aldol as the product. Okay. What is this aldol? Aldehyde alcohol part is there. Ketonic and alcoholic part is there. Okay. But here you may get aldol or ketol. The name of the reaction is aldol reaction. Condensation, here H2O will be removed. Therefore, it is a condensation reaction. Okay. The aldehydes are ketones with alpha hydrogen. With alpha hydrogen can undergo this aldol condensation. If there is no hydrogen on the alpha carbon atom, then it cannot undergo this condensation reaction. Okay. What is the necessary condition? The carbonyl compound must have alpha hydrogen. The condition is aldehyde or ketone. Aldehyde or ketone must have alpha hydrogen to undergo aldol condensation. What is the necessary condition for a molecule to undergo aldol condensation? The presence of alpha hydrogen. Okay, let us see with an example. Acetaldehyde, CH3 C double bond OH. This is called as acetaldehyde. Okay, here with respect to this carbon, this is alpha and it has a hydrogen. So this has alpha hydrogen. Here 2 moles of, let us take 2 moles of acetaldehydes. Okay, yes, this will undergo reaction with a dilute alkali. Because these are having acidic property, no? That's why it reacts with the alkali. Okay. Now, how it undergo? Here, one of the hydrogen will be taken by this H, and again that CH2 will react with this. Okay. Now, how it will be giving you the intermediate like this. CH3 and one of the hydrogen from here it is taken by this oxygen, no? COH, and one H is there on this carbon. Write that H is there, one H is moved here, that remaining is CH2 is attacking onto this carbon. Okay, CH2. Okay, what is left? Again that aldehyde part, C double bond OH. So now, with respect to this is the alpha, this is the beta. Okay. Now, it is a beta hydroxy. It is a beta hydroxy aldehyde. This beta hydroxy aldehyde is called as aldol. Okay. When this is heated or treated with an acid, either it is treated with an acid or heated. Okay, H2O comes out. From this, OH minus comes out, and from this, H plus ion comes out. So during a elimination reaction, there forms a double bond here. Okay, that is CH3, CH, double bond CH, C double bond O, H. This is called as crotonaldehyde. The common name is very important. Keep in mind that this is called as crotonaldehyde. Okay, common name it is. And what is the IUPAC name? This is carbon 1, 2, 3, 4. Okay, this is but. Okay, 2 in 1 Al. But 2 in 1 Al is the IUPAC name. Okay, and this is alpha beta. There is unsaturation between alpha and beta, so therefore it is also called as alpha beta unsaturated aldehyde. Unsaturated aldehyde. This is also called as alpha beta unsaturated aldehyde. See, I am giving you the information from almost all the angles. You need to understand it, and you have to practice after listening to my class. Okay, here the product is crotonaldehyde is the common name, and its IUPAC name is but 2 in 1Al, and it is a type of alpha beta unsaturated aldehyde. The acetaldehyde, because it is having alpha hydrogen, it is acidic in nature, that is why it is reacting with a base, okay, to give an aldol. Aldol is a beta hydroxyaldehyde, and when it is treated with an acid or heated, it undergoes condensation to give alpha beta unsaturated aldehyde. Now the question is, what type of aldehydes undergo aldol condensation? The aldehydes with alpha hydrogen can undergo this reaction. If no alpha hydrogen, it cannot undergo aldol condensation. Okay? Yes. Let us consider one more example, that is for a ketone which is undergoing the aldol condensation. Let us take acetone, CH3 double bond O CH3. This is acetone. Tell me whether it is having alpha hydrogen or not. Yes, it is having alpha hydrogen. With respect to this carbon, this is alpha carbon, this is also alpha carbon. Both are having the alpha hydrogens. These are having alpha hydrogen. Then this is the necessary and sufficient condition for a molecule to undergo the aldol condensation. Yes. Take 2 moles of acetone. I am going to write this like this. This is acetone, this is also acetone. It is to give you a clarity how the reaction is going to occur. Okay. This is when treated with a strong alkali, that is barium hydroxide. It is a strong alkali. It is a strong alkali. Now, hydrogen transfer takes place, no? Okay, from the alpha hydrogen. For example, here the hydrogen, let us rearrange this like this. CH3, CH2, CH3, CH3. Okay, I am just taking this CH3 group here. Okay, that's it. And this CH3 acid. To give you the clarity, the hydrogen transfer takes place from here to here, and this carbon will directly make bonding with this. Okay. Yes. Then let us see. CH3 is here, and this CH3 is not disturbed, and this O is taking hydrogen, no? So therefore it will become OH, and this CH3, one hydrogen is left, only 2 are left, so therefore CH2, and the remaining part is C double bond O CH2. See, this is the alpha carbon, this is the beta carbon. Beta hydroxy. What is this? It is not the aldehydes. It is not CH2. It is COCH2. Means ketone. Beta hydroxy ketone. That is why it is called as ketol. Ket stands for ketone. OL stands for the alcohol. What is ketol? Beta hydroxy ketone. Okay. When this is treated with an acid or heated, delta implies that heating. So H2O will be released, okay, as the byproduct. Now the OH minus will be removed from here, H plus will be removed from here during elimination reaction. It is like this, okay. CH2, from that CH2 I am taking one hydrogen avalanche, and here you have a single bond. This will make a double bond here to satisfy the tetravalence of the carbon atoms, okay. So now the product will be like this: CH3 C CH3 double bond CH CO CH3. In the common system, it is called as mesithyl oxide. Mesithyl oxide. Already we have discussed this mesithyl oxide in the nomenclature of the ketones. What is the IUPAC name? This is a carbon 1, 2, 3, okay, 4, 5. So it is a 4-methyl. 4-methyl. 5 carbon atoms in the parent chain, so it is a pentathreene. And at the second position we have this one. 4-methyl pentathreene 2-one is the IUPAC name, okay. It is also, with respect to this carbonyl, this is alpha, this is beta. It is also a alpha beta unsaturated ketone, okay. This is a alpha beta unsaturated ketone. These are the products. This is all about the Aldol condensation. This is all about the Aldol condensation. It is also undergoing the Aldol condensation. Okay. Here it may be a ketol, but we generally call this reaction as Aldol condensation. Okay. Now, this is the Aldol condensation in similar molecules. Let us consider the cross Aldol condensation. Now, we are going to discuss about the cross Aldol condensation. What is cross Aldol condensation? Aldol condensation is the condensation, Aldol condensation reaction is between the same kind of molecule. Cross Aldol condensation means between different molecules. When you take the different molecules, the alpha hydrogen, whether it transferred from this compound or from this compound, that is again in question marks. And here, if you consider two aldehydes A and B, both are having alpha hydrogens, it may donate the alpha hydrogen and gives one product, and if this may donate the alpha hydrogen, then it gives another product. If A donates to A, that is intra-aldol condensation, gives another product. If B donates to B, then it gives another product. Totally, if both the aldehydes contains, that is both the different aldehydes contains the alpha hydrogens, then there is a chance of getting four products. Okay, let us see that. Okay, case 1. If both the different, that is 2, if both the different aldehydes contains alpha hydrogen, then gives 4 types of products. Okay, two products due to intra-aldol condensation, and the other two products due to inter aldol condensation. Totally we are going to get 4. Okay, let us see with an example. Take the CH3C double bond OH. Take the CH3C double bond OH. This is called acetaldehyde. Okay, and take the propionaldehyde. Okay, this is what? Propanol or propionaldehyde. This is having alpha hydrogen. This is also having alpha hydrogen. This is alpha carbon containing hydrogens, alpha. This is alpha carbon containing hydrogens, alpha hydrogens. Okay. This acetaldehyde reacts with acetaldehyde to give one product. Propionaldehyde reacts with one propionaldehyde gives another product. Intra products are over. Two products due to intra-aldol condensation is over. Let us see inter-aldol condensation. If the alpha hydrogen is transferred from this to this, if alpha hydrogen is transferred from this to this, this is a type A. Let us call this as type A transfer. Let us see the product. Type A transfer of alpha hydrogen. When these are treated with a dilute alkali, okay, you will get a aldol. Listen, both are aldehydes. No, you will get aldol. Okay, how this is transferring? No, so this will be as it is CH3 CH3. After taking this hydrogen, this is OH. This hydrogen is as it is on this carbon. This is becoming CH3CH. This OH is, this H is joining here, so becoming OH. Now this C directly attacks this carbon, so that is what CH. CH3 C double bond OH. This is the product. So on condensation, what happens? OH minus will be released from here, H plus ion will be released from here, so here it will make a double bond. Okay, you will get CH3 CH double bond CCH3 C double bond OH. Okay, now go for it. Type B transfer. Type B transfer is transfer of the alpha hydrogen from here to this. This is called type B. Okay. Type B transfer of alpha hydrogen. That is, if alpha hydrogen is transferred from here to here, this will be as it is. Now let's write that CH3 CH2. Okay, then it will become a CHOH. Then it will be, after losing one hydrogen, it will be CH2. This is that. Okay, and it on condensation. OH minus will be removed here, H plus ion from here. Here you will get a double bond. So it is CH3, CH2. Okay, then CH double bond, and this is CH, CHO. Okay, yes. See, this is what? This is carbon 1, 2, 3, 4, 5. So therefore, this is pent-2-ene 1Al. Pent-2-ene 1Al. This is what? 1, 2, 3, 4. So this is 2 methyl, 2 methyl butene 1 here. So this is a different product, this is a different product. Okay. So here totally we are getting two products due to inter-aldol condensation. If alpha hydrogen transfers from here to here, this is a type B, this you get. If alpha hydrogen transfers from propionaldehyde to acetaldehyde, that is type A, you get this product. And due to intra, that is acetaldehyde with acetaldehyde one product, propionaldehyde with propionaldehyde one product. Totally you are going to get a 4 products when you take two different aldehydes with the alpha hydrogen atoms. Okay, this you need to remember, and it is very important for the examinations also. Let us consider other type where one aldehyde will not be having alpha hydrogen, other one will be having the alpha hydrogen. Let us see that. Okay. These two. Only one reactant is having alpha hydrogen. Okay. Yes, that. What is this? Benzaldehyde. It is not having alpha hydrogen. No alpha hydrogen. Take another one, acetophenol. For example, this. This is called as acetophenol. This is aceto. This is a phenol. This is having a alpha hydrogen because with respect to this is alpha. This is alpha. Here there is no alpha hydrogen because with respect to this is the carbon called alpha hydrogen. It is already having 4 bonds. Now there is no hydrogen. So therefore no alpha hydrogen. All the 4 bonds, here the double bond is connected to this carbon, here the single bond is connected to this carbon, here also carbon. No hydrogen on the alpha carbon. Okay, now what happens? Here, when it is subjected for the alkali, okay, it starts showing its acidic character, means losing a proton. This hydrogen transfers onto this oxygen. Now we get an aldol like this. This becomes OH. This is CH again, and this is becoming CH2. This is C double bond O benzene. This is see, with respect to this is alpha, this is beta. Beta hydroxy ketone it is. Beta hydroxy ketone. So called ketone. Ketone. When this is subjected for heating or for hydrolysis, H2O will be released. Okay. Then we get a alpha beta unsaturated. OH minus will be released from here, H plus ion will be released from here. Here you will get a double bond. Okay. Like this. This is called as benzol acetophenol. This is benzaldehyde. From this you will take benzol acetophenol. Benzol acetophenol. The common name is benzol acetophenol. It is a alpha beta unsaturated aldehyde. This is with respect to this is alpha, this is alpha beta unsaturated. It is a ketone. alpha beta unsaturated. Here you are getting only one product. Getting one product. One product due to inter-aldol condensation and the other due to intra. The other one is due to intra. One product due to inter. Okay, totally you are getting two products. Two products. One due to inter plus another one due to another one product due to intra. Okay, so this is all about the aldol condensation and cross aldol